Hello guys, in today's video we're going to be discussing about mole concept. Now before we jump into the video, I'm going to ask you a simple question. What is 1 dozen? So if someone asks you what is 1 dozen, you're normally going to tell that is 12 something. So if I say 1 dozen of eggs, it means 12 eggs. If I say 2 dozen of eggs, it means 24 eggs. Or if I say 1 dozen of books, it means 12 books. I missed one book. So anyway, 12 books. So similarly, if I say 1 mole, it means this many something. So how we say 1 dozen means 12. Similarly, 1 mole means these many entities. So this is a very big number. So normally we're going to use this big number to refer to something which is extremely small, normally atoms and molecules. So in this video, we're going to be discussing about mole concept and the definition of that. So let's get started. Okay, now let us see how did this huge number come from. So this number is exactly equal to the number of atoms in 12 grams of C612 isotope. So if you take 12 grams of pure C612 isotope, the number of atoms present in that particular sample is these many atoms. Now this number is also called as Avogadro number. So this number is also called as Avogadro's number, and it is denoted by capital N and writing a subscript A. So it is denoted by Na. So now let us see what is molar or molecular masses. So mass of 1 mole of sample of an element or a molecule. If it is an element, it is called molar mass. If it is molecule, it is called molecular mass respectively. So how could you find this? So molar mass of any element could be found using periodic table. So let me explain that. So suppose you have 1 mole of oxygen sample. So you have 1 mole of oxygen. So 1 mole, as I told you, it means 6.023 into 10 power 23. The number, the huge number which I wrote at the beginning. If you write it in exponential form, this is how it looks. Now if you take 1 mole of oxygen atoms, which means 6.022 into 10 power 23, it is a huge number. And if you weigh that, the amount of mass it has is numerically equal to its atomic weight. So oxygen atomic weight, as you know, oxygen 16.8, so is equal to atomic weight but in grams. So the conclusion which we can draw from this particular statement is the molar mass of any element is numerically equal to its mass number in the periodic table. Whereas for molecules, the molecular weight you have to find using a method. So in this you have, I'm taking the example of carbon dioxide. So as you can see, the number of carbon atoms here is 1, whereas the number of oxygen atom is 2. So 1 into mass of carbon atom, which is 12, plus, so 2 into mass of oxygen atom, which is 16. So 12 plus 32, your answer will be 4 grams per mole. So this is the molecular mass of carbon dioxide. I'm going to take another example. I'm going to take C6H12O6. So the number of carbon atoms here is 6 into mass of one carbon atom, which is 12, plus number of hydrogen atom, which is 12, into mass of hydrogen atom, which is 1, plus 6 into 16. And if you simplify this all, you're going to get your answer as 180 grams per mole. So I'm going to recap everything. So the mass of 1 mole of any substance, if it is for element, it's called molar mass. If it is for a molecule, it's called molecular mass. So you can find molecular mass using this particular trick or method. Okay, now let us see what is molar volume means. So molar volume is volume occupied by 1 mole of any gas at standard temperature and pressure. So STP means standard temperature and pressure. And this value is 1 atm. So the pressure value is 1 atm, whereas the temperature value is 273 Kelvin or 0 degree Celsius. So if you take 1 mole of any gas at standard temperature and pressure, and if you check the volume of that particular gas, it is going to be showing as 22.7 liters. And this value is called, and this is a very important value, and this value is called molar volume. And this value is called molar volume. So the last component of mole concept is molarity. So molarity means number of moles of solute in 1 liter of solution. So this is used to check the concentration of a solution. So I'm going to recap about all those things. So as you know, solution is made up of two things. One is solute plus solvent. So second one is solvent, which gives you a solution. So solute is the one which is in the least amount. So whereas the solvent is the one which is in high amount. So molarity is used to check the concentration or strength of the solution. So the formula for this particular component is, so molarity M is equal to number of moles by volume of the solution in liters. So these were the four important components of mole concept. I'm going to write a map of this particular mole concept thing so that it could be helpful for us to easily understand everything. Okay, at last, let us brush up all the concepts, all the components involved in mole concept. So the four components are molar volume, which is volume of the gas, molarity, mass, which is linked to molar mass, and number of particles, which I explained in the beginning of the video. So the number of moles is given in the center. So from the number of moles, if you want to go to number of particles, so you just have to multiply it with Avogadro number, which is Na. So you know the value of Na is 6.023 into 10 power 23. So if you multiply number of moles with Avogadro number, you're going to get number of particles, and if you do the reverse, you're going to get number of moles. Same thing, if you want to get volume of the gas from number of moles, you have to multiply it with 22.7. As you know, molar volume is 22.7 liters per mole. So if you want to go back, you have to divide it with 22.7. Now, if you have number of moles, you have to convert that into molarity. If you want to go from this to this, you just have to divide this number with volume in liters. Remember, in liters. If anything else is given, you have to convert into liters, and then only you have to substitute here. So if you want to go back, you just have to multiply molarity with volume. You're going to get your number of moles. So if you want to find mass of any substance from number of moles, you have to multiply it with molar mass. So multiplying number of moles with molar mass, you're going to get mass of the substance in grams. Or if you want to do reverse, which means if you want to find number of moles from mass of the substance, you have to divide it with molar mass. So this is the detailed explanation of mole concept. You're not going to find any good video better than this in the whole YouTube. So I hope you understood the particular explanation. And if you learned something new, make sure to subscribe to my YouTube channel. And I'm going to meet you in the next video. Thank you.